Bismillah Rahman Rahim. Welcome to the second part again. In this part, we are going to talk about the early history of AI very briefly. And also, I'm going to introduce you to one approach of doing AI, which is trying to emulate the natural knowledge-based systems, the way human beings they approach cognition, how, and trying to recreate that. We will see that in the next part that the modern AI, it makes use of a data-driven approach in which you see lots of examples and then you try to extrapolate patterns from that. You try to make generalizations based on that. But the first approach that we had was a more cognition-focused approach, but people eventually came across stumbling blocks here. They came across problems, and therefore, eventually, this project, although the beginning was very optimistic, eventually there were people who were not very confident about this approach. And when we will get to the third part, we'll see how the data-driven method, the use of big data, machine learning, it changed the face of AI and how it is leading the use of AI and how it is the most popular technique that we find in AI. So let's see and begin our discussion about the early history of AI. So the term AI, artificial intelligence, was coined by John McCarthy. He was an American scientist who was holding a workshop in 1956 in Dartmouth. And he was not alone. He had many people who were working with him on this. The purpose of this workshop was to get together many experts in information technology, in computation, in cognitive science, and get them together to think about how we can create machines that can think intelligently. So John McCarthy, he made up this term. He said this workshop is going to be on artificial intelligence. And one reason for that was just, he wanted it to be different from the other things. There were existing technologies such as cybernetics and other sciences that were working on making intelligent machines. However, John McCarthy coined this term and it became famous. So he wrote this in the proposal of this workshop along with Claude Shannon, the person we see on the right-hand side. He is also a very, very famous scientist. He invented an entire field in engineering known as information theory. So McCarthy and Claude Shannon, in their proposal, they wrote that in this workshop, an attempt will be made to find how to make machines use language, form abstractions and concepts, solve kinds of problems now reserved for humans, and improve themselves. We think that a significant advance can be made if we work on it together for a summer. So they wanted some funding from the funding agencies, and they have described many of the things that we now associate with AI, things such as making use of natural language, having this ability to see many examples and to abstract the general principles and concepts so that then you are able to apply those concepts. It also goes on to describe how AI would aim to solve the problems that was previously or even currently they are thought to be only in the domain of human agency and machines cannot do them. And finally, an important point is the ability to improve themselves. This is known as the problem of learning in AI. So this was how AI started. And I'm going to show you some quotes from some people who also were part of this Dartmouth conference and workshop in 1956. These are all people who can be thought of as, the fathers of AI. They had many contributions to the field. So in the 1950s and the 1960s, people were very optimistic. They were thinking that we would solve this problem in just a few years. And in fact, you would remember I showed you on the last slide, they had even said that we could make a significant progress if we work together on this for one summer. However, despite some progress, the kinds of things that they were envisioning, they were slow in coming. Only recently, we now have some algorithms and some machines that are able to do some of the things that were envisioned at that time. So I will just share some optimistic views of the people who were working in AI then. Herbert Simon said, machines will be capable within 20 years of doing any work a man can do. So such a bombastic claim. We also see this today. However, even today, machines are nowhere close to doing any work a man can do. We are still far from that. However, we are able to even surpass human performance in very narrow tasks. So you would see AI has even defeated the best chess player, the best player of Go. It has a better performance than human beings in some classification task. You're given an image, you have to tell which of the 10,000 classes this image belongs. It can distinguish between dozens of types of dogs. However, for general purpose AI, machines are not as capable as human beings. Marvin Minsky, another famous AI pioneer, he predicted more optimistically that within 10 years, the problems of AI will be substantially solved. And Shannon, he said that I visualize a time when we will be to robots what dogs are to humans, and I'm rooting for the machines. So, there was a lot of optimism and people were thinking that this is the right way to go. And they were only thinking about the positive sides. And even in terms of the timelines, they were very optimistic that this is something that we can very easily do. However, when they tried to do it, they found that many of the things that people had initially thought to be very simple, such as picking up a glass and gripping it in a very So I was saying that in the 1960s, the SHAKEY robot was an important milestone in how AI research was conducted. Before this, the robots were just robotic arms that could move around in a very limited fashion. It could automate things, however, it was not autonomous. In the 1960s, the work on SHAKEY robot was done. This was called SHAKEY because it would shake a lot. But the important thing about the robot was that it had sensors, it had cameras, it had radio links through which it could communicate with the mainframe computer. The brain of the computer was not on the robot, although the robot did have some onboard computers. The real brain was a little far away on a mainframe computer. Many of the things that now we find on modern self-driving cars, the ability to map and to locate yourself on the ground, to find a path to the destination, to avoid obstacles, to interact in natural language. Many of these things were first pioneered in this project. And because of this, this project was given an IEEE milestone award, and which honored this as the world's first mobile intelligent robot. And like I mentioned before, robotics and AI, they have been hands in hand. Robots are embodied AI, but not all AI have bodies. They can be purely software as well, as most of the modern AI is. And a link to a video showing SHAKEY in action is provided. So in the early era of AI, we had knowledge-based approaches. The interest was that there would be a human being who would instruct the machine on how it should do something. So if you have a digit recognition system, you would have a human being, an expert, which would tell the machine that look for these and these things. These are the features through which you can distinguish a 1 and an 8. This is how a 7 differs from a 1. So all of this was initially, especially expert systems were built. For example, for developing diagnosis systems, which can be used for in healthcare. Such expert systems, they try to codify the knowledge that experts have, such as physicians, doctors. However, the progress stalled at a certain place. The idea here was, this is known as traditional programming. You have a computer and you provide it with data as well as a program. And the program actually tells you how to process the data, what patterns to look for. And this requires input from experts. It is a manual process still. The expert is in charge of defining everything, and the computer just follows like a faithful servant. However, eventually this kind of AI, it faced problems, and the problems, they emerged from the fact that constructing such expert systems was very difficult, because to cover all the cases, your system would become very complex. And the other thing is that human beings, they make many decisions based on their intuition, and coding up this intuition was hard. Although you can make a lot of rules, however, such systems were based mostly on logic. And logic is used when you have certainty in your premises, and then you can combine it to produce your conclusions. However, in the real life, you also need to make use of induction, and you need to make use of probability, and you must quantify your uncertainty. The earlier systems were not modeling probability and uncertainty in a very rigorous fashion, and therefore they made progress until a certain level, and then the industry, it basically it came across a bust. And there was a period in which there was very little interest in AI. There was very little funding for AI, and people called this era the time in which the interest, it just vanished. People called it AI winter. This was in the early 90s. As an example, translation was very difficult. So this proverb, the spirit is willing, but the flesh is weak. This is a biblical proverb, which is, I believe, from the New Testament. And the idea is that the person is very weak, even though the person wants to do something. However, when it is translated into Russian and then translated back, because the algorithm does not have any real sense of what is, they are only looking for patterns and they're just matching. At the end of the day, what you saw was something like the vodka is good, but the meat is rotten. The wrong kinds of synonyms are being used. Spirit is here sense in the sense of the human spirit. It does not mean the wine, the spirit, the alcoholic spirit. And flesh here is used metaphorically. It's not used in the sense of meat. So this is the kind of problem we can come when you do AI in a very superficial manner. The expert-based systems and the knowledge-based systems failed because the burden was upon upon the human beings. The experts had to encode all the rules, and it is very hard to encode all the rules. In particular, it's very hard to encode the intuitive rules that we use to make our decisions. And also, it is hard to cover all the cases in real life. We have some sense of how probabilities work, but programming all of that in the early era in a rigorous fashion using the technologies of that time was difficult. And also the problem space, it grew too quickly, and the algorithms, they became very complex. The formalisms we had, the technologies we had at that time were not ready for this, for the kinds of applications we were looking for. So this was a time in which earlier we had a lot of optimism, but then we had a loss of interest. And then we came across the modern era starting in the 1990s, in which we saw an interest in modern AI and the use of data-driven methods. And in this, we could use data, and in the modern era, because of the internet, because of the digital devices, because of the sensors, we have lots of data. We have data generated just as a byproduct of people going around their life in the digital world. So we can make use of this data to learn from experience and to construct models automatically from these data. And these models can then be used to make predictions. These models also got very good at modeling uncertainty and getting a grip on how to model the world of uncertainty. And because of this, they could make probabilistic predictions. Many of the things, many of the predictions we have to make in the real world, they are probabilistic. We do not know with certainty what will happen, but we can differentiate between this is more likely and this is less likely. And this difference is very critical. And corporations figured out that you can make a lot of money by just knowing that this is much more likely than this, and on the basis of that and the basis of this, they created many services that were useful for many people. And we had lots of advances, such as in 1997 the AI algorithm, it defeated the Deep Blue model. It defeated the human chess master. In 2005, a car was self-driven without any driver across a large desert spanning more than 100 kilometers in the United States. And this was a big advance in robotics and in autonomous vehicles. And in 2011, the Watson computer, it made use of lots of computation and lots of data. And through it, it was able to understand questions and answer questions on the famous Jeopardy show, and it won the contest. So this was a big watershed movement in the history of AI. So moving on, in the 1990s, the 2000s, people were looking at statistical approaches. They were making use of probabilistic models, and they could automate many of the things that people were doing manually. So they could, for example, automate feature engineering. People were now not expected to describe to the computer exactly what to look for. You could just instead give it lots of data, millions of images, to automatically detect what features to look for. So this was a time in which there was a resurgence of probability. There was a focus on modeling uncertainty. There was a general increase in the technical depth and proficiency of these AI models, and agents and learning systems were created. And after the AI winter came this AI spring. Again, optimism arose. There was a lot of interest and people could make a lot of money. Google, Amazon, Facebook, these companies, they saw that AI is a very critical tool in their repertoire and they can use it to increase their business a lot. It can also be used to give many services to people. And in the era post 2010, we find that because of lots of data on the internet, if you go onto some site, if you make use of your phone, if you make use of your digital cards, if you make use of your RFIDs, any place you go, your motion, your movement on the internet, everything that you look for, everything that you search for, every site that you visit, it is being recorded. And that this information can be made to you, can be put to use, and through it you can get to know a lot about people. You can model about, you can get a model of their interests, and then you can provide them appropriate services. And this led to the use of AI in many industries. And now AI became intertwined with big data, because the most common technique now used for AI was machine learning, which is you, instead of being provided explicitly with instructions on how intelligence works, you are only provided data, and the algorithm for extracting patterns from the data would form a model for you. And deep learning was a specific kind of ML, which led to a great progress in how various algorithms perform. So on this slide, I show what is the essence of machine learning. The essence of machine learning is that, in contrast to the earlier knowledge-based approaches, you know that there is a pattern in some empirical process, but you find it very hard to describe it explicitly. You find it very hard to describe it mathematically. You cannot say with certainty that this is the relationship. It is a very complex thing. You know, with maths, we find it hard to describe very complex things analytically. You can model, you can simplify the world and create a mathematical model, but that mathematical model is a simplification of the reality. On the other hand, with data, you could create models that would model all of the complexity of the world. And for this, the idea was that instead of the program being given as an input to the computer, you would in fact give information about the data and the associated label. For example, if you are interested in making a classifier that can detect if an image has a cat or not, you would give 1 million images to this computer, and for each of those images, it would say this image has a cat, this image does not have a cat. And the job of the computer is to then use this information, use this knowledge that there is a pattern. It is difficult to describe, but it can automatically just use the power of big data and then inductively learn what is the pattern. And through it, a model is created that can then be used to make predictions. So machine learning, it comes in various flavors. In one way, you are given certain inputs. Here we have labeled it as X1, X2, X3, X4. And in supervised learning, the model, the learning algorithm is also provided information that this is the input and this is the associated label. This is an image and this has a cat. This is an image and this does not have a cat. So in this way, labels are provided, and supervised learning then is able to do various things, such as it is able to recognize digits, it is able to recognize objects, it can detect faces, it can perform speech recognition, it can differentiate between normal email and spam email. So all of this can be done easily with machine learning in a supervised fashion if you have lots of data. So you require millions of instances, in many cases, this is different from how human beings learn. So if you see a child, the child is not shown a million cats and then the child distinguishes between cats and non-cats. The child is able to learn from very few examples. However, these ML algorithms currently they require large amounts of data, and they are very good at extracting information from these examples. Another approach of machine learning is also there, and in this we do not have the labels, but we are able to see that these are the inputs, and then we are able to cluster them, and we are able to see that all of these inputs, they are similar to each other, and these other inputs, they are similar to each other. And in this way, we can form clusters of the input data. We can also do anomaly detection. We can see in a statistical fashion that this is not normal. So for example, in a network internet environment, if you want to know if an attack is happening, you would look for anomalies. What is the normal traffic profile? If a lot more traffic is being created, chances are that the internet service provider is under some attack. So this is known as anomaly detection. This is also used by banks and other people who are interested in security. In this case, in unsupervised learning, in contrast to supervised learning, you're not provided any labels. You're just provided lots of data, and you have algorithms that can just work in an unsupervised fashion. So now we have seen how machine learning works. The real power these days in machine learning comes from big data. So Eric Schmidt, the CEO of Google, he was reported to have said many years ago that there were 5 exabytes of information created between the dawn of civilization till 2003. But that much information is now created every 2 days, and the pace is increasing, and it continues to increase. Now we have large amounts of data because of the use of our mobile phones, the use of our tablets and computers and the internet. Everything is being recorded. You have video images, you have movies, user generated data is being made. You have tracking of location. So with this, you have lots of information available. And the idea behind machine learning is, it is highlighted here in this graph, that as you have more and more training data, the accuracy, it continues to increase and increase, and it starts to approach 100% as you keep on increasing data. So in many cases, you do not even need sophisticated algorithms. If you have lots of data, then even with moderately sophisticated algorithms, you can still achieve great accuracy. You can make predictions, and these predictions are very useful for modern tech companies. How do these machine learning predictions, what kind of predictions and what kind of services we can make use of through this big data? So in essence, there are 4 kinds of analytics. The first kind is descriptive analytics. If you have lots of data and if you're interested in the question, what happened, you would look for techniques that describe the data. If you want to know about why did it happen, if you're interested in diagnosing something, you would look for diagnostic analytics. Sometimes you're interested in what will happen. This is a prediction of the future, and e-commerce companies are particularly interested in this. So on eBay and Amazon, people are interested in seeing, okay, you saw this, and you saw this. Which book are you more likely to buy? This is known as predictive analytics. Remember, this is not certain. You make predictions. Some of them are more probabilistic, more probable, some are less probable, but companies can make a lot of profit on making good predictions. And finally, there is another kind of analytics, which is how can we make it happen? The companies, they are not only interested in making predictions, they also make guesses about, okay, if we change our interface in this way, what is going to happen? And sometimes they have desired end goals in their mind. They want people to buy more, they will change their interface accordingly. And this is known as prescriptive analytics. They have certain ends in mind. And with big data and AI, these big data companies, they have lots of influence. They can change the behavior of people. And again, this is a point where ethical issues arise, because now the question is that these companies can manipulate people, they can exploit people, they have their own agendas, they have their own interests, and they can tweak their algorithms so that you do what they want you to do. This is known as prescriptive analytics. AI gives you all of these powers, and the real promise of AI and how it is currently being used is in predictive analytics and prescriptive analytics. Let me show you some applications of AI, ML, big data. Companies make use of AI and machine learning in business. They look for how people have been using their products, and they make predictions, and then they make their strategy accordingly. This is done not only on the internet, but also in physical stores, because now the data is, the data related to the physical stores is also accessible to the companies, and the data that the online stores have, they also share it, they sell it. And therefore, we live in the world of AI, and people must be aware of the promises and also the challenges of AI. If you go onto a site like Amazon, you're given recommendations. If you go to YouTube, you're given recommended videos. All of them, they come from AI. People make use of analytics in sports. They make use of analytics in their decisions on who to hire, who to fire, who to promote. These techniques are also used in smart services, smart cities, smart buildings. You make something smart by putting in sensors and by collecting data, and then getting your whatever smart thing that you have to respond accordingly. You also have these smart transport services. You may make use of a phone, and you are making use of real-time big data to compute the best path to go through some city or some locality. So now there is this renewed optimism. You see all of these examples, machine translation. You can translate from any language to any language in an automated fashion in real time. And this is obviously very useful to people. It does make mistakes. However, it is very useful. You have the use of machine learning in foreign exchange, stocks trading, object recognition, self-driving cars. They make use of sensors and actuators and AI algorithms. Sometimes even doctors make use of these AI algorithms. Sometimes these diagnoses are done without doctors by making use of algorithms instead. And people are again optimistic about AI, just like we saw in the 1950s and 60s. A famous AI researcher, Andrew Ng, he tweeted a little time ago, AI is the new electricity. Just like electricity transformed countless industries, AI will now do the same. So people are optimistic about technology in the same way. However, there is a need to be realistic and also to take stock of where we really are, so that we are able to see also the pitfalls and the caveats. So I will conclude this lecture segment here. I will inshallah come in the next part to discuss about the modern AI, but in a critical fashion, where we look not only at the positives, but also at the potential risks and negatives. So till then, Assalamu alaikum wa rahmatullah.